So we finally got to the kind of parallelograms most people are always talking about, which in this case is a rectangle, a rhombus, and a square. They all have special properties. So we're going to talk about how they all have specific definitions and how those definitions lead to one another. So you have all the properties of parallelograms, and they are true for each of these special things. But there are also each individual thing that each of these have that others don't have. So that's what we kind of have to concentrate on in this section, is separating the two of them. So for our theorems, I'm going to go ahead and do those. We have that right there, but I also wanted to talk about this up here. So now that we've done the highlighting for all the things you're going to have to copy, I want to look at example number 1. They want us to use the diagram right here to decide whether each statement is true or false. There are sometimes things that go from parallelograms to rectangles, but everything that a rectangle has, a parallelogram has. Sometimes things go from parallelograms to rhombuses, but everything that a rhombus has, a parallelogram has. Sometimes everything that a rhombus has goes to a square, but all the time everything that a square has goes to a rhombus. All the time everything that a square has goes to a rectangle. Some of the things about a rectangle go to a square. So I thought this was a very handy way of putting it. I usually do a family tree of quadrilaterals to try to get this across, but I kind of liked this better. So I wanted to show you that, and I wanted to go ahead and talk about these things over here. All squares are rectangles. Are all squares rectangles? Yes, they are. All squares are rectangles. We know that because it says always when it goes from a square to a rectangle. So that one is true. Every parallelogram is a rhombus. Is every parallelogram always a rhombus? No, sometimes parallelograms are rhombuses. So that one would be false. And then C says some rhombuses are rectangles. Are some rhombuses rectangles? Well, since a rhombus is always a parallelogram and a parallelogram is sometimes a rectangle, yes, that's true, because they said some of them, not all of them. All rectangles are squares. Are all rectangles squares? No. So that one would be false. And then the last one says not every rectangle is a rhombus. Every rectangle is a parallelogram, but parallelograms are only sometimes rhombuses. So that's true. Not every rectangle is a rhombus, but some rectangles are. Okay? So that's that explanation. I know you're sitting there thinking, how can a rectangle be a rhombus? But it will actually hold for some rectangles that they will be a rhombus if they are also a square. So we will talk more about that in the classwork section. Okay, bye.